CuriosityStream is the streaming service for people who want to know more. And now check out Curiosity's new series, The Real Wild West. Rolling Stone magazine says it's the history of the West they usually don't teach you.
The mythology of the West left out a lot of the people.
People said they'd never seen a black cowboy.
This is the history book, but did you know about these other facts?
Watch The Real Wild West now on CuriosityStream. With monthly, annual, and bundled plans, find the one that works for you at CuriosityStream.com.
See care in a new light at Madonna Rehabilitation Hospitals, where top medical minds lift you up, where the very best in specialized rehabilitation brings out your very best, where over 60 years of breakthroughs in research and technology spark your newfound strength. In our world-class hospitals, this is something greater than rehabilitation. It's renewed strength for life. Learn more at madonnarehab.org.
Well, good evening, morning, and hello. Welcome to another episode of Astronomy Daily. It is the 11th of September, 2023. I'm Steve Dunkley, your host. We've got another mixed bag of stories about astronomy, space, and space science for you from around the world, including Mechazilla, SpaceX's new sci-fi landing system, despite Starship being grounded after an explosion probe. The mystery of Polaris's recent change. Polaris is the closest and brightest Cepheid variable to Earth, and something has changed. Chandran 3 is getting chilly, or is already chilly, as lunar night closes in. The probes don't have real heaters and are solar powered, so the prospect of a solar night with ultra low temperatures is a fingers crossed situation for mission controllers. We go searching for extraterrestrial life. We get a JAXA SLIM and XRISM update, and there's a story about a comet that lost its tail. Stay with us, won't you, please?
Astronomy Daily, the podcast, with your host, Steve Dunkley.
Hello there, Hallie. How are you?
Hi, Steve. Nice to be in the studio down under again.
Well, it's always a pleasure to have you with us, Hallie. What's on the menu today?
Hey, did you hear about SpaceX and Mechazilla?
Oh yes, that's the incredible rocket-catching mechanism Elon Musk is building for Starship. We'll hear more about that later.
And what about JAXA's dual payload launch?
Yes, they want to be the next nation to touch down on the moon with their SLIM probe, but that mission has a double feature, and we'll get into that one as well.
Sounds fun. And how about Mr. Nishimura discovering a comet in August? Amazing story.
Well, astrophotographers worldwide have been snapping incredible photographs of Comet Nishimura. If you haven't heard of it yet, you will shortly, because it's making its way through the solar system. The comet was discovered in August, only this year, by amateur astronomer Hideo Nishimura of Kakegawa City in Japan, using only a Canon digital camera with a telephoto lens. Discovering a comet using an off-the-shelf camera is quite an accomplishment, as most new comets these days are discovered with automated telescopes such as the Panoramic Survey Telescope and Rapid Response System, or PANSTARS, which are located in Hawaii. For the past few weeks, comet hunters and astrophotographers worldwide have been following the progress of Comet Nishimura, capturing some incredible images in the process. And you can go to X, formerly known as Twitter, and you should be able to see some great photos of the comet seen by skywatchers from all over the world. Now, you sure can. These next few weeks should be promising for spotting Comet Nishimura. The ball of ice and dust is approaching its closest point to Earth, which it will reach on September 12, before arriving what is known as perihelion, its closest approach to the Sun, on September 17. The comet is currently making its way through the Leo constellation in the early morning hours just before sunrise. To see this spectacle, look to the east in the pre-dawn hours. A stargazing app might be your best bet to help you locate the comet, while binoculars or a telescope should help access a good solid view of this. Through binoculars or a small to medium-sized telescope, expect to see a fuzzy greenish orb, but with more high-powered optics you should be able to resolve the comet's tail itself. Notable comet hunter Michael Jaeger of Austria has captured a plethora of breathtaking images of Comet Nishimura through the September period so far, and earlier this month he even caught the comet lose its tail in what is known as a disconnection event. due to, well, Hallie, what do you think would make a comet lose its tail?
Solar wind or a solar storm. There was an event like that recently, so it would have disturbed the tail, of course.
Well, that's right. Coronal outgassing or solar wind was disruptive enough to make the comet's tail dissipate from view. But then the same photographer was able to recapture the comet with its tail back in place again. In fact, a few days later on September 5, Jaeger photographed the comet having regrown a well-pronounced tail. Nick Bull, who is well known for his Stonehenge dronescapes, posted a beautiful photo on X, formerly known as Twitter. I'm going to have to say that every time, aren't I? Of the comet in the skies above Stonehenge on September 6, perfectly framed above the prehistoric stone monument. So you should go and take a look at that image and the other images that are posted on X of Comet Nishimura. Once-in-a-lifetime event, everybody. And now, Hallie, why don't you give us the short takes?
No worries, here we go. When you look up in the night sky and find your way to the North Star, you are looking at Polaris. Not only is it the brightest star in the Ursa Minor constellation, also known as the Little Dipper, but its position relative to the North Celestial Pole less than 1 degree away makes it useful for orienteering and navigation. Since the age of modern astronomy, scientists have understood that the star is a binary system consisting of an F-type yellow supergiant, Polaris AA, and a smaller main sequence yellow dwarf, Polaris B. Further observations revealed that Polaris AA is a classic Cepheid variable, a stellar class that pulses regularly. For most of the 20th century, records indicate that the pulsation period has been increasing while the pulsation amplitude has been declining. But recently, this changed as the pulsation period started getting shorter while the amplitude of the velocity variations stopped increasing. According to a new study by Guillermo Torres, an astronomer with the Harvard and Smithsonian Center for Astrophysics, these behaviors could be attributed to long-term changes related to the binary nature of the system, where the two stars get closer to each other, and the secondary perturbs the atmosphere of the primary. Cepheid variables are stars that pulsate radially, causing them to vary in diameter and temperature. These pulsations are directly related to changes in their brightness, which makes them a useful tool for measuring galactic and extragalactic distances. The variable nature of Polaris was confirmed in 1911 by Danish astronomer Ejner Hertzsprung, for whom the Hertzsprung-Russell diagram is partly named. Observations conducted throughout the 20th century have shown that Polaris has a consistent pulse period of about 4 days, which has been steadily increasing every year. As Dr. Torres explained today via email, this recently began to change, leading many astronomers to question what is driving Polaris pulsations. For more than 150 years and up until about 2010, the period had been getting longer by about 4 or 5 seconds each year, he said. Modern observations have shown that this trend has now reversed, and the pulsation period is getting shorter. This is an unexpected change, showing that there is still much that we do not understand about Polaris and other stars like it. To learn more about Polaris pulsation period, Torres consulted radial velocity, RV, measurements going back to 1888. This technique consists of measuring spectra from a distant star and looking for redshift and blue shift, which are indications that the star is moving back and forth. This technique also yields accurate estimates of its velocity. Torres' sample included more than 3,600 RV measurements, including the nearly 1,200 spectroscopic observations carried out by the Lick Observatory over more than 60 years. This allowed Torres to trace the evolution of the pulsation properties of Polaris, which showed how often pulses occur and their amplitude as well. NASA's quest for extraterrestrial life now includes technosignatures, evidence of advanced civilizations on distant exoplanets. Through AI, new research methods, and a broadened focus, scientists remain hopeful in discovering life beyond Earth. Our first confirmed proof of life beyond Earth might not involve biology at all. It's possible that we might intercept communication through electromagnetic waves, like radio, or find telescopic evidence of epic engineering. While the search remains largely focused on non-technological life, NASA scientists also have begun to consider what technological traces of intelligent life, technosignatures, might look like. They wouldn't come from planets in our solar system, but rather from far-flung exoplanets that we cannot see up close. Among the possibilities are laser or radio pulses, signs of artificial chemicals in the atmospheres of distant planets, or Dyson spheres, massive structures built around stars to collect their energy. As acceptance in the scientific community slowly grows, a field once derided as a search for little green men is showing early signs of blossoming into a mature, serious investigation. That's something we've worked very hard on, to establish our legitimacy and distance ourselves from pseudoscience, said Jill Tarter, an astronomer known for decades as a leader in the search for intelligent life beyond Earth. If anything, my conviction that this is an important and reasonable thing to do has increased. Tarter is the co-founder and former director of the Center for SETI, Search for Extraterrestrial Intelligence Research at the SETI Institute, as well as the inspiration for the main character in Carl Sagan's 1985 novel A Contact. She says one of the biggest challenges today is moving the search for signs of technology beyond just radio signals. We still want to look at all the sky all the time, at all wavelengths, Tarter said, including pulses of laser light that might be used for communication. Another challenge is short-lived, transient signals, one-time events that can be bright and energetic. Mixed among the many natural sources for such signals, like gamma-ray bursts or supernovae, might be artificial transients from distant civilizations, an engineered signal lasting less than a few minutes. But teasing them apart likely would require enormous amounts of computer time. We're trying to figure out how to do that, Tarter said. That is our focus now. Artificial intelligence could prove an ally in such searches. Sophisticated algorithms can sort through large amounts of data for patterns that could indicate an engineered signal. And AI searches likely would have fewer of the possible biases of human analysts, who might tend to focus their search on types of signals they've defined in advance, or view as more likely. SpaceX's Starship, the most powerful rocket ever built, must remain grounded while Elon Musk's company completes dozens of corrective actions to prevent a repeat of the spectacular explosion that marred its first orbital test flight, regulators said Friday. The 63 steps include redesigns of vehicle hardware to prevent leaks and fires, redesign of the launch pad to increase its robustness, additional testing of safety systems and more, the Federal Aviation Administration, FAA, said in a statement after completing a months-long review. SpaceX blew up the uncrewed rocket 4 minutes after it blasted off from the company's star base in Boca Chica, Texas, on April 20. Starship experienced multiple engine failures and its first-stage booster did not separate from the spacecraft above it. The rocket disintegrated into a ball of fire that crashed into the Gulf of Mexico, while a cloud of dust floated over a small town several kilometers away. Musk immediately congratulated his SpaceX team on an exciting test launch and declared it a success because the company would gain valuable insights into what went wrong. The FAA, however, quickly launched an investigation, while conservation groups announced they would sue the regulator for not doing enough to protect the environment given the proximity of a vital habitat for protected species. Though the probe has now been completed, the closure of the mishap investigation does not signal an immediate resumption of Starship launches at Boca Chica, said the agency. SpaceX must implement all corrective actions that impact public safety and apply for and receive a license modification from the FAA that addresses all safety, environmental and other applicable regulatory requirements prior to the next Starship launch, it added. And finally, after a groundbreaking 2-week mission, India's robotic Chandrayaan-3 explorers are fast asleep in the frigid darkness of the Moon's South Pole region. Whether they'll wake up when the sun shines down on them at the end of this lunar night mostly whittles down to luck. Temperatures near the Moon's poles can drop to as low as -424 degrees Fahrenheit, -253 degrees Celsius or 20 K. Yet neither Chandrayaan-3's lander, Vikram, nor its rover, Pragyan, which made a historic touchdown on August 23, are equipped with heaters otherwise common for moon missions. These heaters, called radioisotope heater units, RHUs, work by passively radiating heat to keep the hardware on board spacecraft at sustainable operating temperatures. Most commonly, RHUs used in space missions convert heat generated from the natural decay of radioactive versions of plutonium or polonium into electrical power. This process ultimately warms spacecraft hardware, though mostly just enough to help it survive very cold temperatures. But without such power systems, the survival of Chandrayaan-3's robotic duo is left to chance. And that's the short takes for today.
You're listening to Astronomy Daily, the podcast with Steve Dunkley.
Oh, I can relate to those poor little probes on the moon. That's freezing in the cold lunar night. It's only a few days into the Australian spring, and I'm freezing. I can tell you that right here in the studio, it is absolutely freezing. So I don't want to turn on the heater because you'll be able to hear it through the microphones. I've got a very noisy heater, and I know that's a long way away from what's going on in the real world. But anyway, as always, a reminder that you can always find back episodes of Astronomy Daily and our parent podcast, Space Nuts, with Andrew Dunkley and Professor Fred Watson at bitesz.com. That's bitesz.com, and also spacenuts.io. And one more thing, once again, I'll remind you, don't forget to sign up for the Astronomy Daily newsletter at that same address. That's bitesz.com and also spacenuts.io. And now here's the next bit. Just when you thought SpaceX couldn't outdo themselves, they've gone and invented a new way of landing their boosters and rockets. SpaceX has tested its new Starship catching launch tower. Yes, you heard it. This was announced about a year ago, so it's not new news, but they've released a video recently that has just knocked my socks off. SpaceX has installed a pair of rocket-catching arms on a tower meant to support the first east-to-coast launches of its next-generation Starship rocket. The company has been building the second of several planned Starship launch sites for more than 3 years. Ironically, the work on that pad began before the company started building the pad that will actually support Starship's first orbital launch attempts. Located at a stone's throw from the Gulf of Mexico in Boca Chica, Texas, the first iteration of SpaceX's Starbase Orbital Launch OLS is nearly complete and could host Starship's orbital launch debut in a matter of months. SpaceX began constructing Starship's Texas launch site in earnest in late 2020. SpaceX has shown us in recent years how science fiction can quickly become reality, with rapid-fire routine rocket trips to the ISS and new developments in landing systems that are straight out of the old movies. And it's the latest rocket landing concept that has got tongues wagging all over spaceflight community. It's one thing to land a used rocket booster on a barge or a landing pad, which sounded at the time like a crazy idea. But now take a look at how SpaceX plans to land the big Starship rocket. Yes, the big one. The same tower that will be used to launch the rocket will also attempt catching the spent booster when it comes back to Earth, because NASA's trepidation at the thought of Starship failure indefinitely delaying SpaceX from completing its Crew Dragon or Falcon Heavy contracts for the agency, the company deprioritized Starship's Florida pad, slowing progress. SpaceX has, nonetheless, made significant progress. In 13 months, SpaceX has created foundations, modified one of Pad 39A's giant spherical tanks to store cryogenic methane, installed miles of plumbing, built and assembled a second skyscraper-sized Starship launch tower, installed the legs of the pad's orbital launch mount, or OLM, installed a water deluge system at the base of the OLM, assembled most of the OLM's donut-like mount off-site, constructed a new supersized storage tank, and delivered a forest of smaller storage tanks. Most recently, SpaceX finished building a giant pair of steel arms, transported the arms to Pad 39A, attached them to a wheeled carriage, and installed the structure on Starship's Florida launch tower. SpaceX employees have nicknamed the arms chopsticks, and those arms are integral to what CEO Elon Musk calls Mechazilla. Mechazilla refers to the combined launch tower and arms, which SpaceX has designed to grab, lift, stack, and fuel both stages of Starship. Mechazilla's simplest part is a third arm that is vertically fixed in place but capable of swinging left and right. The swing arm contains plumbing and an umbilical device that connects to Starship's upper stage and supplies propellant, gas, power and connectivity. The tower's chopsticks are far more complex. Giant hinges connect the pair of arms to a carriage that grabs onto the three of the tower's four legs with a dozen skate-like appendages. Those skates are outfitted with wheels, allowing the carriage to roll up and down tracks built into the tower's legs. The carriage, which also carries the complex hydraulic systems that allow its bus-size arms to move, is connected by steel cable to a heavy-duty drawworks, capable of hoisting the multi-hundred-ton assembly up and down the tower. Once finished, the Florida Tower's arms will be able to precisely lift, maneuver, stack and destack Starship and Super Heavy, even in relatively windy conditions. At some point in the future, SpaceX may attempt to use its towers and chopsticks to catch Starships and Super Heavies out of mid-air and speed up reuse. Set to be the largest, most powerful and most capable rocket in history, Starship is primarily built out of steel and designed to be fully reusable. SpaceX has a long way to go to demonstrate that the 120-metre tall rocket can reach orbit, let alone be reused. In theory, though, Starship is meant to launch up to 150 metric tons to low Earth orbit, while still allowing for the recovery and reuse of its suborbital Super Heavy booster and orbital Starship upper stage. If SpaceX can achieve these figures, Starship will be the most capable rocket in history, even with the major performance penalties that full reusability entails. Saturn V, the most capable rocket ever flown, was fully expendable and could launch up to 118 metric tons. Due to NASA's concerns about the risk that Starship launches from Pad 39A could pose to SpaceX's Falcon and Dragon operations at the same site, the company's next-generation rocket may have to wait until 2024 or 2025 for the first Florida launch. With the first Florida Mechazilla now close to completion, it's likely that Pad 39A's Starship launch site will be ready and waiting as soon as NASA gives SpaceX the green light. Well, they were only 10 days late launching, but they got off the ground nonetheless. Japan joins the new race for the moon with its launch carrying the Slim Moon Lander and X-RISM, or X-ray telescope, on a space double-header. A few months from now, the Slim Moon probe will hopefully make a lunar history landing try. Yes, Japan sent 2 ambitious missions soaring into the heavens. That was on September 6, as we reported at the time. This mission carrying the pioneering lunar lander and a powerful X-ray telescope. You may recall in last week's Monday episode of Astronomy Daily, I mentioned that a Japanese H-2A rocket carrying the Slim Moon Lander and the X-RISM space telescope lifted up from Tanegashima Space Center about 10 days later than originally planned thanks to weather delays, but both spacecraft were deployed on schedule, sequentially less than an hour after liftoff. And if all goes according to plan, a few months from now, SLIM, which stands for Smart Lander for Investigating Moon, isn't that just a gem, will attempt to pull off Japan's first ever soft lunar landing, a pinpoint touchdown that will pave the way for even more ambitious feats down the road. SLIM aims to achieve a lightweight probe system on a small scale and use a pinpoint landing technology necessary for future lunar probes, officials with JAXA, Japan Aerospace Exploration Agency, said in a mission description. The project will aim to cut weight for higher function observational equipment and to land on resource-scarce planet with an eye toward future solar system research probes, they added. SLIM is a small spacecraft, roughly 1,540 pounds or 700 kilograms, but about 70% of that is propellant. SLIM will take a long, looping and fuel-efficient route to the moon, finally reaching lunar orbit 3 or 4 months from now. It will then eye the lunar surface for another month or so before attempting a touchdown inside Scioli Crater, a 1,000-foot wide or 300-metre impact feature that lies at a 13-degree south latitude on the moon's near side. The probe aims to land within 330 feet or 100 metres of a target point within Scioli crater, a more precise touchdown than previous lunar landers have attempted. The goal is to demonstrate pinpoint landing tech that could open the moon and other celestial bodies to more extensive exploration. By creating the SLIM lander, humans will make a quantitative shift toward being able to land where we want and not just where it is easy to land, as the case has been before, JAXA officials wrote in the mission description. By achieving this, it will become possible to land on planets even more resource scarce than the moon. SLIM also carries 2 mini probes, which will be ejected onto the lunar surface following touchdown. Those 2 little craft will help the mission team monitor the status of the larger lander, take photos of the landing site, and provide an independent communication system for direct communication with Earth, according to JAXA's mission press kit. SLIM isn't the first lander that JAXA has built. The agency's tiny Omotenashi craft was one of 10 CubeSats that launched with NASA's Artemis 1 moon mission in November 2022. While Artemis 1 succeeded, Omotenashi did not. Its handlers couldn't establish communication with the little probe in time for its planned touchdown. Several of the other Artemis 1 CubeSats failed in their mission as well. And a Japanese lander has tried its hand at lunar touchdown before. The Tokyo-based company iSpace Hakuto R lander reached lunar orbit, a huge accomplishment for a private spacecraft, but crashed during its touchdown attempt this past April. Success by SLIM would therefore be historic. Just 4 nations have soft-landed a probe on the moon to date: the Soviet Union, United States, China and India. India put its name on the exclusive list just last month when Chandran 3 touched down near the lunar south pole. As exciting as SLIM is, it's merely the secondary payload on this particular mission. The main spacecraft is XRISM, which is headed for a perch in low Earth orbit. XRISM, short for X-ray Imaging and Spectroscopy Mission, is a collaboration involving JAXA, NASA and the European Space Agency. Its full name suggests the telescope will study the universe in high-energy X-ray light. X-ray astronomy enables us to study the most energetic phenomena in the universe, Matteo Gianassi, ESA project scientist for XRISM, said in a statement. It holds the key to answering important questions in modern astrophysics: how the largest structures in the universe evolve, how the matter we're all ultimately composed of was distributed through the cosmos, and how galaxies are shaped by massive black holes in their centres, he added. The observatory will focus particularly on the super hot gas surrounding galaxy clusters. JAXA has designed XRISM to detect X-ray light from this gas to help astronomers measure the total mass of these systems, ESA officials wrote in the same statement. This will reveal information about the formation and evolution of the universe. XRISM won't be the only X-ray telescope studying the heavens from Earth orbit. Also up there right now, for example, are NASA's Chandra X-ray Observatory and ESA's XMM Newton, both of which launched in 1999, as well as NASA's New Star, which lifted off in 2012. And just like that, we've come to the end of another episode of Astronomy Daily. I'm Steve Dunkley, your host from Down Under, and it's been an absolute pleasure being with you again. I hope you will join us again next Monday from the Down Under studio. Tim Gibbs will be with you on Friday from Bath in England, and Hallie, of course, will be skipping between us at the speed of light. Thanks again for joining us, when we will be bringing you all the stories from around the world to do with astronomy, space and space science. See you again. Bye.
See you next time.
Astronomy Daily, the podcast, with your host, Steve Dunkley.